వెల్కమ్ టు ATL ఆన్లైన్ సెషన్. అందరికీ స్వాగతం, సుస్వాగతం. నేను భాగ్యశ్రీ, ఫ్యాకల్టీ SCRT AP. థ్యాంక్స్ టు ఎవ్రీవన్ ఫర్ వాచింగ్ ATL sessions. Thanks to the Department of School Education, Samagra Shiksha, SCRT, UNICEF మరియు విజ్ఞాన్ ఆశ్రమ్. ఇంతవరకు జరిగిన సెషన్స్ అన్నిటినీ కూడా విద్యార్థులు, టీచర్స్ అందరూ కూడా చూసి వాటిని ప్రాక్టికల్గా చేసి మీరు నేర్చుకున్నారని మేమంతా అనుకుంటున్నాము. సరైన ఫలితాలు వస్తాయని మేము ఆశిస్తూ ఉన్నాము. త్రూ ATL సెషన్స్ యు ఆర్ గోయింగ్ టు లెర్న్ సంథింగ్ బియాండ్ ద లిమిట్స్. Because this is the scientific, we have to reach the scientific temperament, we have to get the knowledge beyond our expectations. Today's session is timer integrated circuit and its applications. దీనిని ఈరోజు మనతో పాటు విజ్ఞానాశ్రమం నుంచి ప్రథమేష్ గారు మరియు రాజీవ్ గారు మీకు ఈ సెషన్ గురించి కంప్లీట్గా ఎక్స్ప్లెయిన్ చేస్తారు. కాలాన్ని గుణించగల ఇంటిగ్రేటెడ్ సర్క్యూట్స్ మరియు వాటి యొక్క అప్లికేషన్స్ ఈరోజు మనం విందాం, నేర్చుకుందాం, చూద్దాం. వెల్కమ్ టు ద సెషన్. ఓవర్ టు ప్రథమేష్.
Okay, thank you, ma'am. We'll just start with our presentation. Okay. Today this is 9th session of ATL ATL Tinkercad Way to Innovation Nirman series, learning through tinkering. In previous session, we talk about some energies like potential energy, kinetic energy. We talk about light. What are the different spectrums of light? We talk about infrared sensor. We talk about LDR sensor, light dependent resistor, where it is dependent on intensity of the light. Okay. So today we are going to discuss about timer IC. Timing. What is the time? What is the timer IC? What is the timer? Why we use actually some timing devices like clock to see what time it is and its applications. Okay. So we'll go to objective of our session is get to understand what is the time. How we measure the time in ancient days and today. Okay. What is an IC? IC means integrated circuit. What does it mean? Okay. What is a timer? Okay. Why we need a timer? Application of integrated circuit 555 timer. Okay. Tinkercad. What is Tinkercad and its application for understanding the circuits? Okay. These are the things we are going to cover for today's lecture. Okay. Previously we have done a project, automatic water tap. Okay. Can you guess what is there is something wrong in this project? When can you guess what it is? I am playing the video again. Okay. Did you find something? Okay, we'll discuss it about it in our next slide. During our previous session, when we built automatic water tap with the help of infrared sensor, we understand that we made the system automatic. We don't need to touch it anymore. Okay, water tap will be switched on and off automatically. Okay, but when we take the utensil away from the sensor, it does not turn off the tap immediately, and a little bit of water get wasted. That we have seen in our last session, last video. So we thought we can reduce this wastage if we introduce a timer circuit, which will allow water to flow for limited time. That is like 10 seconds. Okay. Then even there is utensil in front of infrared sensor, tap will be automatically turned off, and only for it will be on only for 10 seconds, and then it will be turned off. That's why let's first understand how to use 555 timer IC and count the time. Okay. What is the timer? Timer is a clock that controls sequence of events while counting the in fixed interval of time. Means we need something to count fixed interval of time. Currently, our clock, they calculate 1 second. They calculate fixed interval of time of 1 second. Okay, a timer is used for producing precise time delay. Okay, what is IC? IC stands for integrated circuit. Okay, we know little bit about the circuit that we made on the our breadboard. Okay, but what is this integrated circuit? Okay, integrated circuit is combination of electronic circuit on a small semiconductor chip. Even when we made our circuit on the breadboard, it took lots of space. We need to integrate some diodes, some uh, resistor, some of the transistor, some of the capacitor. But what if this all can be done on a single chip? Okay, and that circuit is known as integrated circuit. Okay, this is consist of a simple black chip which will consist all the particle which you need. Okay, this entire circuit is accumulated only entire this chip, and we have got only 4 and 4, means 8 total pins. What are these pins for? Let's see on another slide. Okay, what are these pins? These pins are ground. First number pin of IC 555 is ground. Second pin is trigger. Third pin is output. Fourth pin is reset. Fifth pin is counter. Sixth pin is threshold. Seventh pin is discharge, and eighth pin is VCC. Okay. Some of the pins we know, some of we don't know. We know some ground, VCC, output, and trigger, and reset pins. Almost we have used them for something, but we don't know about discharge, threshold, and count pins. Okay, let's understand in that IC 555 in details. Okay, pin specifications. What are these pins are meant to? Pin 1, grounded terminal. This means all the voltages measured with respect to ground terminals. Okay. Pin 2 is trigger terminal. Trigger pin is used to feed trigger input. Okay. Here we have to connect something which when we want to start or stop the time. That's why we are using this trigger terminal. Output terminal. Output of this timer is available at this pin. Okay, when the timer should be on or when the timer should be off, that output will get on the output pin. Reset terminal. Whenever the timer IC needs to be reset, a negative pulse is applied to pin 4. Then our timer circuit will be reset. Okay, if you have used the Arduino board before, then you might know about reset button, what it does. Okay. Fifth pin, control voltage terminal. The threshold and trigger levels are controlled using this pin. Okay, threshold terminal. This is the non-inverting input terminal of a comparative. Yes, sir, it is not necessary right now. Uh-huh. Pin 7 it is a discharge terminal. This pin is connected internally to the collector of the transistor, and mostly capacitor is connected between this terminal and ground. Okay. Supply terminal. A supply voltage of plus 5 volt to plus 18 volt is applied to this terminal with respect to ground. What we need to make a timer circuit? We need a 555 timer IC, we need a breadboard, we need a resistor, we need a capacitor with 0.1 microfarad or 1 microfarad capacitance, 9 volt battery, LED, switch. Okay, this is a circuit diagram which we will be seeing in our next slide. Okay, First of all, I would like to say thanks to the students of APS WRS Rangapuram School who helped us to build this circuit. Okay, just day before yesterday, they have built this circuit and tested it. Okay, here we'll explain you about we are going to use a software called as Tinkercad. In Tinkercad software, we can simulate our connections and whatever the resistor or capacitor we are using. Let's see this video. Okay, here we are making the circuit which is explained in this figure. Okay. We need to connect the capacitor number 2. Okay, let's see how they have built the circuit. We have seen a video where we have explained how to connect the connection on the breadboard while using the software called as Tinkercad. Okay, here I'm giving you a slide where we have entirely placed the circuit. You can try this circuit on your own. Okay, uh, then I will explain this circuit to you. How to calculate means how much time actually our timer will produce. How to calculate that time if we require a delay of 12 seconds, let's say our tap needs to be on for 12 seconds, then how we are going to do that? We need to do some calculations. How to calculate this time? Output pulse width, how much time, for how much time our tap should be on, that will be calculated in second, is equals to, that formula for that is 1.1 into R1 resistance 1 into C1. C1 is capacitance. Okay, here we have 50 kilo ohm resistor used and a capacitance of 220 microfarad. Micro indicates actually 10 raised to minus 6. That's why we have kept this value as 10 raised to minus 6. When we do this calculation, we come to know that it will give us 12.1 seconds delay. Okay. Some things about time. Do you know the units of time? Time is measured in seconds, in minutes, okay, in hours, or in days, in year. Okay. Why this time is important for everyone? Why do we need to measure the time? Why it is so important to measure the time? Okay, it is important because we require to go through our history and keep track of our historical events, whatever the actually happened. That's why we remember our birthday, we remember anniversaries, we remember various things, because we are actually able to keep the track of the time. How many seconds will make 1 minute? Okay, 60 seconds will make a 1 minute, and 60 minutes will make a 1 hour. Okay, then we made the circuit out of 555 timer IC, which will generate 12.1 seconds delay. But actually, what is time? Time is measured in units, like time measured in units like seconds, minutes, hours, day, months, or years. Because Earth rotates around the sun in approximately 24 hours. We call a day is of 24 hours. But for different planet, the day can be of different timing. Then how we are going to measure the time? Like Venus took 243 Earth days to complete a one single day. That it means it approximately have 125 days night and 125 days sunlight. Okay, Mercury will have 59 Earth days to complete one day. That means it will have 30 day, 1 month of darkness, 1 month and 1 month of light. Okay, Mars will have similar. Mars is having similar to Earth, means like 24 hours. It will be having like 24.30 minutes to complete a one day. Okay, Uranus is very fast, faster, not very fast, but faster than our Earth. It will complete its one day in 17 hours. Okay, Neptune will complete its day in 16 hours. Jupiter is fastest one. It will complete its one day in 10 hours only. Okay, if we when we went to some other planet, then how we are going to keep the track of the planet, track of the time? Okay, that's why we are moving towards some digital or electronic timers, because the timers we are using in ancient days were cannot be used on different planets or on different location other than Earth. Okay, then what we have done, man was measuring the time in history. How he is measuring the time in history? He is using a sand clock. This first image you can see, it is having some sand in a inverted tube, which sand will be flown towards the in lower chamber. Why? Because sand is gravity is applying some force on the sand, so sand will come in below chamber, downward chamber. Okay, the time which required to flow the sand from upper chamber to the bottom chamber, it is a unit time. Okay, it can be calculated, it can be designed for 1 minute, for half a minute, for 1 hour. Okay, uh, But what is the difference with can we use this equipment on Mars or on Moon? No, because acceleration due to gravity is different. So it will pull the sand with different rate. Okay, it will be a unit of the time, but we don't know. We did not build this machine to measure the time on some different planet. Okay, the second one, it is the shadow clock. It uses a shadow of the sun to indicate the time. Okay, but it will be useful only in daytime, not in nighttime. Using utensil with small hole underneath. This utensil will be get filled with the water because it have a small hole, okay, underneath, and it will get filled because of water. Okay, it is also a unit of the time, means 1 unit of the time we can measure with this small utensil. This is how our ancient peoples are measuring the times. But how we are measuring the times? We are measuring the times with atomic clock. What are these atomic clocks? We can measure the time intervals, the duration between two events. Okay, most accurately with atomic clock. This clock produces electromagnetic radiation such as microwave with precise frequency that causes atoms in the clock to jump from one energy level to another. Cesium atom makes such quantum jumps by absorbing microwaves with frequency of 9 into 10 to the power 9. Okay, that much division of a second it can do. Okay, which then defines the international scientific unit for a time, the second. 1 second means what? When cesium atom absorbs the microwave with the frequency of 9 into 10 raised to 9 times, then it will be 1 second. Okay, because this is measuring the time this much precisely. Okay, we will have very less error while measuring the time using a quartz crystal. Quartz crystal is a second most accurate thing to use, which is used in digital and analog clocks. Okay, using a capacitor and resistor, the help of 555 timer IC. Okay, we understood how the atomic clock will count the time. We understood how quartz crystal will count the time, but we don't know how capacitor can count the time. Okay, if we let's see about the capacitor. Capacitor is an electronic device which can store the charge. Okay, charge is electrons. It can store the electrons. It is similar to small water tank, but instead of water, it store charges. If we have some small bottle, water bottle, it will store the water. Okay, if we have a capacitor, it will store the charges. Okay, so if we can assume that we have some water tank, if we have some water bottle, and we if we dig some hole in the water bottle, it will emptied in some unit time. Okay, the time required to empty a bottle will be constant because it have constant volume of the water. Okay, similarly with the capacitor, if we can discharge it with a constant rate, it can be it can set as a unit of the time, 1 unit of the time. Okay, so how can we use the capacitor then? Let's see. As shown in the figure, once in this circuit, this is actually water circuit. Here water pump is there, which is taking water from this tank and putting into upper tank. Okay, then we are using it to drive some turbine. Okay, when pump is on, water will be get filled from this tank to this tank. Okay, when this tank will be filled or filling, the turbine will be get rotated. Okay, but when we stop the motor, the water the turbine will not be stopped instantaneously because it have some remaining water over here. Okay, even if we stop the motor, the water inside the upper tank will drive the turbine. Okay, then for some time after removing the power, after some time, the our system will be working continuously. Okay, let's compare capacitor similar to small water bottle. Okay, similarly, capacitor will store the specified charges, and when we use these charges, they will flow, and after some time this capacitor will become chargeless, and again this time will be same for every time, will be same every time if we connect the same load. Okay, let's talk about Tinkercad. We we talk about capacitor, but let's give a practical example of the capacitor through Tinkercad. Tinkercad is an open source platform for 3D designing. Okay, electronic circuit simulation. Today, we will see how to use the Tinkercad for checking our circuit works or not. Okay, how to open this platform online? We need just to go to www.tinkercad.com. Today, we are just going to see how simple circuit works with without capacitor, with and without capacitor. Okay, you just need to go to this site and need to log in with your Google account. Okay, here in the circuit we will having a proper video of the Tinkercad in upcoming session, but we'll see difference between the capacitor and without capacitor circuit. Okay, here the first circuit is simply a battery, a switch, resistor and a LED. Okay, here I have connected an ammeter to voltmeter to measure the voltage across the LED. Here the same thing is repeated, but just we have added a capacitor. Let's see how these circuits work. Okay, when I turn on this switch, our LED glows. When our LED glows, the voltage across this circuit is 1.95 volt. Okay, and when we switch it off, instantly it becomes voltage drop down and our LED becomes switched off. But let's see in this circuit, when I switch this circuit on, it will instantly start the LED. Okay, and the voltage across the LED is 1.95 volt. But just because we have added the capacitor, it will not be getting switched off instantly when we switch off this circuit. Okay, let's do that. When we switch off the circuit, still our LED is working because, and the voltage across the LED is 1.89 volt. It is dropping, but it is dropping at certain rate. Okay, and gradually it is dropping. In previously, it was directly dropped down to 82.2 millivolt, but here it is dropping gradually, and gradually our LED is dimming. Okay, that is why, because we have inserted a capacitor into the circuit which have already stored the energy. When we switch on the circuit, again it will goes to 1.95 volt, and when we switch it off, it will be in on condition. Okay, let's go back to our presentation. Okay, do we actually need to measure the time? Yes, we do need to measure the time. Why? Because we need to measure time because we want to know how much time a process would require, so that then we would know how much time we need to spend to complete a process, or we can like time required to heat the water. If we have kept some water to on the heater, so we can assume that 10 minutes will be required to heat this water. Okay, time required to fill the overhead water tank, that we can assume, because when we once we keep the track of the time, we require to keep track of the time, so we can predict the timing of occurrence of some natural events. Okay, we require to keep track of time to understand the historic events. Okay, applications of 555 timer. The IC 555 is used for tone generation. Tone is some electronic equipment, electronic instrument which plays the music. They use 555 timer IC to generate the specified tone. It is used to make alarm circuit. Okay, because it can generate a precise time, it can generate an alarm. They can also use to digital counter circuit. Digital counter circuit means when we need to count something, count some objects like things, then we can use the timer IC also. IC 555 is widely used for electronics project. That's why we have studied it. Okay. Thank you everyone. Rajiv, my colleague Rajiv, will you explain more about this?